Hi and welcome back everyone. Tabiso here, back with another nice and exciting lesson, mathematics. Today we are geared towards IGCSE trigonometry. Trigonometry is a huge section in mathematics, very important section to study. So it's really good to do it well. Okay, it's worth doing well. So let's get on to our today's lesson. Introduction to trigonometry. We will be looking at the fundamentals functions in trigonometry. Okay, right, here we go. Suppose we have a circle that is inscribed on a Cartesian plane. So you have your plane, two-dimensional plane, x and y, and you have a circle with center at the origin inscribed into this Cartesian plane. Okay, your horizontal axis, which is x, and your vertical axis, which is y. No surprises there. Now suppose that we have our center as the pivot for a ray that is sweeping across this two-dimensional space here. Okay, so as this ray is sweeping, obviously we have different angles being formed as the ray changes direction vectorially. We have different angles being formed with respect to our horizontal x-axis as our reference axis. So all those angles there are the angles that are formed as the ray is sweeping across this plane. In trigonometry, we want to understand, or we want to study further how we can define this rate of change in terms of radians, in terms of angles, as well as this ray is being swept across or around this pivot point or this center here. If we take one such ray, now let's freeze one such ray. Right, so if we freeze the ray there, at that point there, which is a certain point of length x away from the center, and that point there, which is a certain point away from the center, that point obviously being parallel and equal in length to that other length there. Now imagine that we have a right-angled triangle being formed between our x and our y, obviously there. This angle, therefore, we will call it angle alpha or beta or theta. Doesn't really matter. Okay, I'm going to call it angle theta. Now we can define at this point, that frozen point, we can define the lengths first. In trigonometric ratios, we can define the lengths of those those dimensions there. We can also define the angles in terms of trig ratio or fundamental trigonometric ratios. Okay, not going too much into detail and the history of trigonometry and where it came from, but we are going to look at these three fundamental functions for today: the sine, the cosine, and the tangent. Yes, I know. I didn't say the sin. It's sine. It's written sin, but please, it's pronounced sine. It's not sin because the full name is S-I-N-E. So we abbreviate it, okay, as S-I-N, but it's still pronounced sine, not sin. This is the cosine, and this is the tangent, abbreviated S-I-N, abbreviated C-O-S, or cos. You hear people saying cos, and abbreviated tan. You hear people saying tan. Another thing I want you to please make you aware of, it's the sign of something. It's a sign, always a sign of a reference angle. The sign of, in this case, sign of theta cosine of theta or cos theta, and the tangent of theta or tan theta. Okay, we define the sine of theta as being equals to sine of theta is the opposite side divided by the hypotenuse side. Now, in this circle here, this is the center, this is the circumference of the circle. Our hypotenuse side is the radius r. So the sine of theta is opposite, which is y, divided by the hypotenuse side, which is r. The cosine of theta is defined as the adjacent side, x, adjacent to the angle, x, divided by the hypotenuse side, which is r. The tangent of theta is defined as the opposite side, which is y, divided by the adjacent, which is x. Tan x is equals to y. Tan theta, beg your pardon, is equals to y over x. It's a very nice mnemonic rhyme we use to remember all of that. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. The tangent is opposite over adjacent. We can also use so, ka, toa. I'm sure you've heard of this. SOHCAHTOA. SOHCAHTOA. Okay. So means sine of an angle is equals to opposite of that angle divided by hypotenuse of that angle. Ka, which is cosine, cos of an angle, is equals to the adjacent, adj, divided by hyp or hypotenuse side. Toa, which means the tangent of an angle, is equals to opposite divided by adjacent of that angle. Okay, these functions, sine, cosine, and tangent, have what we call reciprocal functions, sometimes called inverse functions. I would like to call them reciprocal functions. The reciprocal of sine, cosine, and tangent, if something is a reciprocal, then we can represent it as, just gonna erase that there for now, right. Reciprocal functions or inverse functions, okay. Reciprocal functions. If something is a reciprocal, then it can be, let's say you have a number 2. The reciprocal of 2 is 1 over 2. The reciprocal of 5 is 1 over 5. So the reciprocal of 3 over 4 is 4 over 3. Okay, I'm sure you are seeing a trend somehow here. This is the same as 2 over 1, so you reciprocate it. You swap your numerator and your denominator, and that becomes your 1 over 2. That's why I'm very skeptical in calling it an inverse. 5 divided by 1, that's the same as 1 over 5. 3 over 4, the reciprocal is the same. The reciprocal is 4 over 3. Hence, your sine, cosine, and tangent reciprocals then. Okay, so your sine of theta, the reciprocal of sine of theta is 1 over sine theta, and the special trig name for that reciprocal is cosecant of theta, also abbreviated as cosec. Okay, the reciprocal of the cosine of theta is 1 over cos theta, which has a special name secant theta, or abbreviated as nice 3 letters sec of theta or secant of theta. And tangent of theta becomes the reciprocal 1 over the tangent of theta, which is the cotangent of theta and abbreviated as cot of theta. And those are reciprocal functions. Sine theta, reciprocal, cosecant. Cos theta, reciprocal, secant. Tangent theta, reciprocal, cot of theta. Okay. Remember that we also defined in terms of that, in terms of our right-angled triangle, we defined the sine of theta. We said sine theta was equals to y, which was the opposite, over r, which was our hypotenuse side. Therefore, cosec theta is equals to r over y, reciprocated. Sine was opposite over hypotenuse. Cosec will be hypotenuse over opposite, or r over y. Secant of, cosine of theta, we define the cosine of theta as x over r. Therefore, the secant becomes r divided by x. And the tangent of theta we defined as opposite over adjacent. Tan theta, the opposite is tan theta, the opposite was y, adjacent was x. So the cot of theta will be equals to, yes, well done, tan was y over x, cot will be x over. Nice one. You are getting there. You are getting the basics. I'm really glad, guys. Well done. Now, all of what we've covered in the past 12 minutes, you are going to hear a lot as we go on with trigonometry over and over and over and over again, improving in proofs, I beg your pardon, in trigonometric equations, in functions. You are going to see a lot of this, and we build from these fundamental identities. The next thing we are going to look at in our next lesson is special angles. Okay. Thank you very much, guys. Please repeat this as often as you want to. Repeat this lesson. Learn these, know them well as often as you need to, so that they are engraved within yourself and you will be successful in your trigonometry. Thank you very much. Have an awesome day. Bye.